Everyone, we're starting the arc length and sector area notes. We're going to start with the arc length section. So these notes are made so that you can cut the paper in half right through here, and so that it's like a little foldable for you to open. So we're going to go across and we're going to start with arc length. So arc length. So I have this picture of a pizza here because this is what I used to help my students kind of like figure out what we're doing. And so I want to emphasize that we can use any circle, but I chose pizza because everybody loves pizza. And so for arc length, we're going to be looking at the measurement of, think of like the pizza crust, right? So that's why I have that drawn on there. And so if you have a highlighter or something you like to use to color coordinate, you might want to highlight this part of the circle, which is the arc length. So again, if we're talking about pizza, it would be the crust, okay? And for this formula, we have to know the measurement of the degrees of the circle that we're looking at and also the radius. So let's get started over here. We're going to start with the baby steps. So the first baby step is circumference. So circumference is something that you may have learned in 7th grade or 8th grade, but it is the distance around a whole circle. So we're talking about distance, and when we talk about distance, we're thinking of measurements like centimeters, millimeters, inches, yards, meters, that type of thing. So it's a calculation of a length or distance. And the formula for that is circumference equals 2 pi times your radius. Or you could also do pi times the diameter, depending on what the problem gave you. Okay, so those are the two formulas you have. And in Delta Math, the problems that you'll be doing will make you use both of these equations. So just for reference, this is for when you have the radius, and this is for when you have the diameter. Just a little key to remind you. Okay? And that is level 0, our circumference, okay? Finding the distance around the whole circle, all the way around. But arc length is not the whole circle. If you see here, I did a little visual so you could kind of see that arc length only is a portion of the circumference. So because of that, it is a different formula for that arc length. And it's also a different type of measurement. We're measuring the arc length of this part of the circle. So because of that, since we're not using the whole circle, we need to figure out what part of the circle are we using. So this is the part of circle or portion times the circumference. I'm just going to abbreviate, times the circumference. So that's what arc length. So that's where the x divided by 360 comes from, because we know that a full circle is 360, but we need this amount of degrees, whatever the problem gives you. So let's do some examples. We're going across. So in your notes, it's across this way. The first one is circumference. And this one is also circumference. So for both of these, we're looking at the whole distance. I'm going to highlight to help us see the difference. And for arc length, it's only a portion of the circumference. So a portion, not the whole thing. Okay, so just a portion of it. All right, and the formulas are here. So for the first one, it says find the circumference, round to the hundredths. So based on the image they gave me, this is obviously a diameter length, 8.2. So I'm going to choose to use this formula, pi times diameter, okay? So let me copy it. Circumference equals pi times diameter. And then you just go at it, plug it in, pi times 8.2. And then we let Desmos be our best friend and do the math for us. So open up Desmos Scientific and you go to pi times 8.2. 8.2. And it's 25.76. So they want me to round to the hundreds. So circumference equals 25.76. And we're using feet here in this problem. All right. Okay. I want you to pause the video and try to do C here for circumference. So here's the formula. Okay. And then see if you can figure this one out and use the correct rounding skills. All right. Okay, hopefully this is what you got, 52.15 yards, all right? Let's move on to arc length for these two. So arc length, my formula was arc length is equal to the portion of your circle out of 360 degrees times your circumference, which is 2 pi r, okay? Now, let's look at our picture. Who does the 10 represent in the formula? Does it represent the degrees or the radius? It represents the radius, okay? The 145 would be the degrees of that portion. So I'm going to calculate this many degrees with a 10-inch radius. And then you just plug it in. So 145 is the section I want out of 360 times 2 pi r, which is 10, okay? And you take all that and you plug it in to Desmos. So 145 out of 360 times 2 pi times 10. And Desmos says that it is the arc length 25.3. The number after the 0 is a 7, so 1. And what measurements am I using? Inches. Okay. All right, so that is arc length. I want you to try to do D and see if you can figure it out. Okay. Let me copy the formula. Or if you're just going to sit there and watch me do it because you don't want to practice on your own, hey, all power to you. I'm just going to do what I need to do. So. All right, so I subtracted from 360 because the portion of the degrees that I needed was not given to me. They gave me the bottom part, and I don't need that section. I need the top. So I needed to subtract from the total, which is 360 degrees in a circle, and then that gave me 150. And then I can plug that in to Desmos, and it is 39.27 inches. All right, so that is arc length for you, and circumference. The difference, remember, is circumference, you're finding the length of the entire circle, the distance, and for arc length, we're finding a portion of that circumference. And we have to use our degrees, okay? Go ahead and go to the next video for sector area. Thank you.